next up, we have Manfred. I'm not sure if everyone is aware, but actually Manfred has been part of NGB from our first edition for every edition since our existence. So it's really, really nice to have you again. And it's always such a pleasure, and we learn so much from you. So
Same bias, thank you.
Yeah, thank you to you. So good luck with your talk. Please give him a round of applause.
Okay, cool. Great, so thanks for having me. I want to get started with a fairy tale. I am quite sure you know it. Do you know it? The three little tiny piglets. And you know the story, it's about the first piglet. It was a bit lazy, I really like it, but it built its house with straw. And it was done quite quickly, and so it had a lot of time for doing body. And it was similar with the second piglet. It built its house of wood, and so also it was quite quickly done, and so it had a lot of time for doing body. However, the third piglet used a brick stone house, a solid brick stone house, and it was a lot of effort. It was really a lot of effort, but it paid off. Because when the bad wolf arrived, then he destroyed the straw house, he destroyed the wood house. He was not capable of destroying the brick house. And so the piglets could hide there. Great story, isn't it? Great story. The effort paid off. It's also a nice metaphor for software architecture. Such a nice metaphor. Such a nice metaphor. And beyond being nice, this metaphor is also wrong. It's wrong. I'm very sorry. It's the wrong metaphor. Because if this metaphor tells you the more the better, then you come to the wrong conclusion. It's not the more the better. Your parents lied at us. First the Easter rabbit, Santa Claus, and now the free piglet they told us about. Because if you ask me, it's a spectrum. And on the one side of the spectrum, we have under-engineering, doing too little, which obviously leads to code that is hard to be maintained. But on the other side of the spectrum, we have over-engineering, which also leads to code that is hard to maintain, because we have a lot of unnecessary indirections we need to follow. And if you ask me, it's more an art than engineering to find the sweet spot in the middle. However, the latest innovations in the world of Angular help with finding the sweet spot and help with reaching the sweet spot. And this is what the underlying question of this presentation is about: how to meet the sweet spot of my Angular architecture with those latest innovations. For this, I have prepared three things for you. We get started with standalone components in general. We will look into them and find out how they enable us to build a nice architecture. Then we go on with custom standalone APIs, which is also a nice way to hide implementation details of your very own reusable software parts, libraries, or perhaps just parts of your project you want to share. And then we will talk about functional services. Okay, let me also introduce myself before we get started. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. I'm doing a lot of workshops and consultancy around this topic. Besides this, I'm also quite connected to the Angular community. I live in Austria, I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the globe. Okay, let's get started with the first topic I've prepared for you. It's about standalone components. You know, back then when Angular 2 was ready for prime time in 2016, we got ng modules. We got them again. They have already been in Angular 1, and then we got them again with Angular 2. However, this led to some confusion, because suddenly we had two module systems we needed to deal with. First of all, we had TypeScript modules, ECMAScript modules, import, export, and then we had those Angular modules. And somehow it was confusing, and if you have not been confused, it was at least annoying for you to type everything 2 or 3 times and to have all those interactions. And hence, I'm really happy that since about a year, we have standalone components. They arrived with Angular 14. Back then, they have been a developer preview, and now they are production ready since Angular 15. Standalone components are basically components that can survive on their own. They are self-sufficient, and that means they don't need any module. You can just take them and use them. To mark a component as standalone, you just set this standalone flag to true, and then you need to import the so-called compilation context of the component. Compilation context, or as I call it, the neighborhood of the component. Everything you are allowed to use within the template of the component. That's necessary because now without modules, no one tells us about this. We need to know this by ourselves. So let's put it in there. However, it is somehow exhausting to maintain this import list. And that's why we need some automatism. And here I have a click dummy for such an automatism. It's about writing something like this in your templates. For instance, we are calling my component, we are using ngIf, and then something needs to happen. Someone needs to appear. I'm sure you know him. He hasn't been around for quite a time. Clippy. Clippy needs to appear, and Clippy has to ask you, hey, Manfred, it looks like you want to use ngIf and my component. Shall I import it for you? And I say, yes, of course. And then Clippy maintains this import array. Yeah, this was my vision. The vision was implemented by the Angular team. Unfortunately, without Clippy, I'm very sorry. But what we see here is a tweet from Dylan Hann. He is with the Angular team. And already last fall, he tweeted about his work. And he told us that he is starting to implement such a feature for the Angular language service, which is used by a lot of different editors and IDEs. And here you see how it works. You type in the component name, you get the quick fix, you click on it, and then pops your uncle, you get your imports array maintained. I think this is quite important to make use of this cool feature. Besides this, the big question, however, that arises now is, what does this mean for our architecture? How can we structure our application without modules? Or to put it in another way, how to do modularization without modules? And for this, I have a first quite simple answer for you. You could just go with a sound folder structure. Just structure your application according to features, and it should be fine. You could go one step further and define such a barrel, an index.ts, that acts as your public API. Everything you are exporting here can be used by other parts of your system. Everything you are not exporting here is your little tiny secret. And trust me, it's a good thing to have little tiny secrets, because everything you keep a secret can be changed afterwards quite easily. You can throw it away, you can buy it from a third-party vendor, you can completely rewrite it. However, everything that is publicly published cannot be changed that easily, because other people, other parts of your system depend on it, so better not break it. If you ask me, this is a simple strategy, but a very effective one for building a stable architecture. The Angular team itself is using this strategy, and they think twice or perhaps even 3 times before they publish something for the rest of us. The next step would be to subdivide your huge application into domains. This is especially important if you have a huge system. Then what you want to do is you want to subdivide it into parts that don't know much about each other. And very often, those parts mirror some things in the real world, some areas in the real world. Here it's about an airport system, and you see I have a domain boarding, I have a domain check-in, I have a domain luggage. So somehow we try to subdivide everything into parts that don't need to know much about each other. And of course, in there, we can structure everything one more time according to features, because each and every domain has a lot of features. Here we can even go one step further. We can use a linting rule that prevents us from grabbing over to another domain. In this case, you see, boarding is not allowed to directly interact with check-in. It's not allowed to directly interact with luggage. It's not allowed to directly interact with ticketing. It only is allowed to use something from the shared folder. And this is called. Such a restriction that is enforced by a linting rule is called. Because this prevents that everything depends on everything else, that everything is intermingled with everything else, and so you have a stable architecture. An architecture that enables you to change something here without breaking something there. I think you all know about this situation, regression, as some people call it, and yeah, it's always a disaster. So the big question now is, how can we implement such an access restriction? And for this I have two answers. The first answer is we could go with NX. NX is a beautiful build system for monorepos, and it comes with a lot of tools. And one of those tools is a linting rule for preventing access between libraries. If we talk about NX, we have those restrictions on a library basis. If you want to have it a bit more fine-grained, you can use a brand new open source project my Angular architect's colleague Rainer Hanekamp wrote. And it's called Sheriff, the Angie Sheriff. You know, there is a new sheriff in town. And it does the same. It is highly, how do you say? It is following those ideas from NX. And it does the same on a folder basis. That means this allows you to have even a more lightweight architecture that is just using folders, but nevertheless, you have those access restrictions. Yeah, he published it yesterday in a first version. He worked on it for the last weeks. The first version is, I think, a 0.something, so perhaps you'll revisit it in some weeks when he publishes version 1. It really has a lot of potential, so follow us for more information on this next weeks. Okay, cool. So the next question is, how can we migrate over to standalone? Because I'm quite sure all of you have existing code. So somehow we need to move over to standalone. And for this, I have identified 3 strategies. The first strategy looks a bit funny at first glance, but it's really a valid one. I call it the ostrich strategy. After this silly bird that sticks its head into the sand, you know. It's a survival strategy in the public sector, as I learned when I worked there several years ago. But nevertheless, I know it looks funny, but it's a valid strategy because standalone is just an option. They don't want to force you into migrating. You can stick with your code base as is. They really did a lot of effort so that everything works seamlessly together between the new world with standalone and the pre-existing world with ng modules. So you don't need to hurry and worry. The second strategy is what I'm calling mix and match. You can really mix and match the new and the old world. That means you can just begin with implementing new stuff in your project with standalone. Everything works seamlessly together. Here you see it. I have a standalone component that imports an existing module. That means we can use existing stuff with standalone. It also works vice versa. If we have an existing module, for what reason ever, we can import a standalone component. Plus, when bootstrapping our application component, our app component in the main TS, we can also provide some providers, provide some services. And if your services are part of an existing module, you can take them out with this bridging function, import providers from. Takes out the providers from the module and puts it here where you use it normally together with standalone stuff. The third option is a migration. you migrate your existing code, and the good message here is there is a schematic for this. It's quite new. It has been around for some weeks. It arrived with the last minor version of Angular 15.2. And it's more or less a matter of doing this command, ng generate Angular core standalone. So let me show you an example for this. What I have here is a pre-existing application. No, not here, but here, a pre-existing application, and it uses modules. This is here a typical app module. Look at this. Yeah, okay. So as you see, a lot of stuff in there. Of course, no one would do something like this in the real world. But yeah, here in this example, it happened that I have quite a huge app module. And now let's try to migrate all of this. Let's shorten the prompt. Let's increase the font size. And generate Angular core standalone should. So it takes some time, and then it gives me 3 stages. I need to go 3 stages. In each and every stage, a little tiny bit is migrated. And at the end, the application should be fully migrated over to standalone. We start with converting all components, directives, and pipes to standalone. Then we remove unnecessary modules, and then we bootstrap the application using a standalone component. That means we don't point to an app module that has somewhere a bootstrap array that points to the app component. No, we directly point to our app component. We directly bootstrap it. You need to go through those steps step by step. And here, because of time limitations, I just focus myself on the first step. The nice thing about this idea is, this idea gives you the opportunity to check the migrated source code after each step. So if the automatism was not capable of converting everything, you could help it a bit by moving stuff around by hand. It works quite nicely, but of course, there are some things, especially library-specific things, this automatism cannot foresee. So let's get started with this here, convert all components. Now I could say, well, please only migrate a portion of my application, this folder. Here I'm saying, please migrate everything, because this application is quite small. But also, if you had a huge application, also here, migrating it little by little would be a good idea, I guess. Yeah, and now it does its job. And we will see it migrates several components over to standalone components. For instance, my flight search component. Let's copy-paste the name. Let's go in here. It's now standalone. And it also found out about the neighborhood of the component. The compilation context is in here. I need the forms module, a validator, ngIf, ngFor, and so on. This is really quite nice because it's a huge help for arriving in the new world. Okay. So let's proceed with the second topic I've prepared for you. It's about custom standalone APIs. As you know, we have those helper functions here. They call it standalone APIs or sometimes provider factories. And they set up libraries, like you see it here, the HttpClient or the router itself. They also implemented a naming pattern here. The Angular team wants to encourage us to follow this naming pattern. In order to provide services for a library, there should be a provide XYZ function. You see it here, provide HttpClient, provide router. And for activating optional features, there should be with functions, like with interceptors, with preloading. The nice thing about this is that those with functions make our source code better tree-shakeable. Suddenly, parts of the router and parts of the HTTP client are tree-shakeable. This is quite funny because as a byproduct of moving over to standalone, the application bundles become smaller. If you don't use a feature like those, it's tree shaking away. And now the idea is to do something similar for our own libraries. This would allow us to hide implementation details or the services we need behind those functions here. Here I implemented this idea for a Locker service, for a Locker library I implemented. Provide Locker with a Locker config. The thing is, in general, you should be careful with this pattern. In general, you should follow the golden rule, namely, whenever possible, use provided in root. It's really frictionless, it's straightforward, it's easy to use. So whenever possible, go with provided in root. And by the way, this even works with lazy loading. Because if this service is only used in the lazy portion of the application, then the bundler will put it there. However, you cannot use this golden rule when you need to pass a configuration, like this Locker configuration here. This does not work, and so I would encourage you to go with a provider function in this very case. Let me show you an example for this. For this, I'm switching the branch. Force checkout. Here we go. And now I'm moving to my main file. And here we see I have a Locker library, a highly reusable Locker. I can also increase it a bit for you. But in order to use this Locker, we need to provide all those services here. We need to provide the Locker service itself. We also need to provide a Locker config so that the Locker knows if the bug messages should be logged out or error messages should be logged out. There is a log formatter that formats the log message nicely before writing it out, and an appender that might send it to the console or to the backend. So it's quite powerful. However, if the consumer of this library does not need those possibilities of exchanging all those services, it's an overkill. It's a frustrating overkill. And this is exactly where my provider factory comes in. Because if we had a provider factory, we did not need to know that this Locker consists of all those services. We just needed to call the function. So let me show you in another branch my factory for those providers. It's just a matter of calling this function here, provide Locker. In the middle of my providers array, I'm passing in when bootstrapping the application. That means if the consumer wants to use the library as is, they can just go with a default implementation, and they don't need to use all those options here. Although the configuration options are optional. But if they want to tweak everything a bit, then they can look into the API and find out how to exchange a formatter, how to exchange an appender, and so on. So it's more or less a black box for the consumer, which is good. And if we look into this provider factory, then we see it is just a simple function. A simple function, provide Locker, it takes a partial configuration, and it returns an environment providers object. The environment providers object is just a wrapper, you see it here, for an array with providers. They wrap this array with providers because they won't avoid us, using the type system, to use those functions with components. We all know we can register providers with components, but normally we don't register whole libraries with components. If you register the router with just one component in the component decorator within the providers array, you would have bad luck because the router has never been prepared for this. It has been prepared to work on a global level and for lazy parts, but not within a component. And that's why the Angular team gave us those special type that is nothing else than some kind of wrapper, because this wrapper just works with the global providers, with providers in a lazy root, but not with providers in a component. And this factory takes care of it. So here, first of all, I'm merging my configuration with a default configuration, because my configuration is partial. If the user is fine with the default settings, they just get them. They don't need to mention anything. And then I'm registering everything I need. The logger service or the logger config, which is just my merged configuration, or my custom log formatter, if there is any. It is also part of the merged configuration, or some log appender, if there are any, and they are also part of the merged configuration. So basically, it's a function that returns the providers, and so the consumer can just use this part, this reusable part, as a black box and sometimes as a gray box. Another strategy for improving your architecture. Okay, so let's move over to the third part I brought with me today. It's about functional services. You know, in the past, it was quite usual that a service was a class. And this was also quite usual for services we implemented for Angular and building blocks in there like the router. Santosh already told you about this. Now can activate as a function. Before, it was a class that implemented an interface. The interface forced you into implementing a can-activate method. The class was annotated with injectable and registered as a service, and then the whole service was registered here. So you see, there were some interactions. And now it's really straightforward, isn't it? We have just a function. We get hold of some service with the renewed injector function, and then we call another method there and Bob's your uncle. It's really straightforward. I worked with this in the last weeks. I migrated some software on this new style, and I can tell you, it really feels right. And of course, if this is not just one line, but several lines of code, you can put those lines of code into a separate function. It's also less work than the whole game with the class that is implementing an interface and so on. We have the same situation with resolvers. Resolvers are also now functions that can get some stuff via inject. And we can do the same with interceptors. Who has used interceptors so far? Yeah, a lot of people. Cool, cool. It's one of the best features of the HTTP client, if you ask me. Interceptors allow you to modify all the outgoing HTTP requests and also the incoming responses. You might use it to append an access token to all the outgoing requests and to parse the payload of the incoming responses. In the past, this also was a class with an interface and blah, blah, blah. Now it's as easy as a function that takes the current request. You can modify it, and when you are done, you are calling next, so that the next interceptor is triggered, and if there is not a next interceptor, the intended HTTP action is triggered. And if we go one step further, we could also use this strategy for our own code. I think it's a good candidate for situations where you would have one class with just one method. In those cases, you can completely convert it just to a lambda expression. That means you use a provider factory or some provider by yourself in order to set up your function as a service. Makes things a bit easier and more straightforward. So if you say, well, this was a nice presentation, I liked it, look up my ebook. I wrote down a lot of stuff about those topics. It's free, you can find it here. And if you did not like this presentation, you know, download the ebook anyway. Perhaps I'm better with writing than with speaking. Yeah, some people are taking a picture. appreciate this. Okay, cool. So let me come to a conclusion. What did we see today? What did we talk about today? Well, first of all, I told you that the new way of using Angular allows us to go with more lightweight architectures. And this helps us to find the sweet spots between under-engineering and over-engineering. Both is bad. We have also seen that standalone components make everything more straightforward. They take out unnecessary indirections and they make hence Angular more lightweight. And there are even migration scripts that help you to migrate over to the new build. We talked about standalone APIs, especially about custom standalone APIs that help you to hide implementation details of parts of your application. However, those providers can also give you a configuration object to exchange. And so you can tweak the existing implementation a bit if you want. If you don't want, you just go with the black box with the library as is. And last but not least, we talked about functional services, also streamlining everything a bit more. And there is one last thing I want you to remember. Please, 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 do not let them tell you too much fairy tales. So that's it. Thanks for having me. Here you find my contact data. I have already uploaded my material on my blog. You find it here, and follow me on Twitter to keep in contact. Thank you.